In this Newton's second law lab, we are asked this guiding question: what is the relationship between net force and acceleration? So we have the procedure of what it is that we're going to do. We have the data that we collected that we got from the velocity versus time graphs. And we see that we have the total weight here that's taking the mass on the hanger times that 9.81. That's that acceleration due to gravity, the gravitational field strength. So we have the mass on the hanger times that gravitational field strength, and then we're getting our acceleration data. So we got this from looking at the velocity versus time graphs. So what you're going to need to do is you're going to need to now do the analysis of this, get the average acceleration, and from that you're going to be able to get the data to answer this guiding question. So what I'm going to do is I'm going to click here to make a copy of the data table and to make a graph. So I'm going to click here, and when you click on that, it opens up this. So you're going to see our acceleration trial 1, trial 2, trial 3. You're going to get this over here. What this is doing is this is calculating the average of it. So we could do the average where you take 1 plus another, divide by 3, but we have an equation that does it already. So right now there's 0 data points over here, so it's dividing by 0, so it tells us some erroneous data. So what we're going to do is come back over here, highlight the data from trial 1, 2, and 3, Control C to copy, bring it back over to our our Excel spreadsheet, or Google Sheet rather. You want to make sure it's that way all this data goes into this region here. So I'm going to click on the top left. When you paste into a Google Sheet, it pastes below and to the right. So I'm going to paste here, Control V to paste my data, and then it pastes my data into this data table, allowing now the acceleration data to populate there. I'm going to also go back and copy my net force. That is the force from this hanger, the tension force on the hanger. So I'm going to go Control C to copy that. And back over to my Google Sheet, I'm going to click on the net force. When I Control V and paste, it pastes below, but it recognized that I had the word net force on there already. So I have now my net force and my average acceleration. I'm going to copy this average acceleration, Control C, and I'm going to bring this over to my data table. And so now I can click onto the actual cell for my data table, and I'm going to Control V to paste it in, and the data is pasted in, so now I don't have to add all these values up and divide by 3, it's already done for me. I'm going to also make sure I get a copy of my graph so that way I can copy and paste this graph in. So when I want to do that, I get onto my graph, onto my sheet. I click on the 3 dots in the top right hand. This is where I'm going to copy my chart. When I copy my chart, is now going to come back over here. I'm going to paste this, Control V. I want to paste this unlinked, so that way the graph now is embedded in here as a picture. Even if the data gets changed, manipulated, it will always be in here, this graph. And I see I have a linear relationship where it increases over time, but we're not dealing with time. We're increasing here acceleration. We have an increasing net force. So force is on the y-axis, acceleration on the x-axis. So that means right in here, this slope is telling us how the force changes due to an acceleration, or rather how an acceleration can then change the net force. And we're going to see that this 0.556, that's the slope. And what we're going to do now is we're going to try to do our analysis questions. On this very first one, as the force increased, what happened to the car's acceleration? Well, we know that as the force increased, the acceleration increased. We can see it graphically. We see it graphically. And we also see it numerically. We see it numerically in our data table. So what I mean by that is you have to actually say, well, you can see it here with this net force of a 0.245 newtons. We had a 0.43 meters per second squared acceleration, going up to a net force of a 1. We have an acceleration around 2. So it's much bigger as that force increased. We can also then say what the mass of the total mass of the system as well as everything in there. So we have the mass of the cart is this 0.4987 kilograms. That's the mass of the cart that was moving. We also have everything in the cart. That was the hanger and all those masses as well. That's 0.105 kilograms. If we add them up, the system mass has this 0.604 kilogram mass. So what you should be seeing is that the mass 0.604 is pretty close to this 0.556. And what that is telling us is that the mass of the system compares to that slope in this equation. What we're getting to is that force on the y-axis, y equals mx plus b, so force on the y equals to something on the x-axis, that's acceleration. So force equals mass times acceleration, where the mass is this 0.556. So the slope is close to the mass of the system. So when we get to the CER, we're trying to answer this guiding question: what is the relationship between net force and acceleration? So your claim will need to have something about this force being equal to mass times acceleration. And what we're getting to on that is more net force means more acceleration. If you double the force, then the acceleration doubles as well. And that's for your claim. When you're getting into evidence, you have to use data. So use data from this experiment. So like when the net force was this 0.245 newtons, we had an acceleration of a 0.43 meters per second squared. When you had a net force of 0.834 newtons, we had an acceleration of 1.43 meters per second squared. So that's calling in some of the data, but the data itself is not enough. You can also need to use the graph as well. So you need to point out information on the graph. So you need to point out that this graph has this linear relationship with the slope, and point out what the slope is and what that slope represents. And then in your reasoning, you're trying to involve that this graph is linear. You also need to say something along of a linear relationship and what that gives to us with that slope, and how this slope of the linear line using y equals mx plus b gets us to I'm just using this is an arrow. This leads us to that F equals ma, because on your graph you had force on the y-axis, and you had on the x-axis you had the acceleration, telling us that that slope then is this mass. Because you didn't change the mass in our Newton's second law lab, we kept the mass constant. Only the net force was changing, and thereby changing that acceleration of the system. So you need to say something about this linear relationship, and that linear relationship leading us to that this F equals to ma.